Alright, so today we're going to look at transition matrices. So a transition matrix can be used to describe a scenario that you're changing. It's what they often say, they change from one state to the next. So generally it can be anything. It could be like you are using it to predict, say, maybe the chances of it raining from a day-to-day basis. So what is, they collect some data, they create this transition matrix, and we then use this transition matrix to predict what we might see in the future or to find out what we'd see and so on. So we've got a couple of facts we need to remember about the transition matrix. So you'll see a transition matrix will be a square matrix. So it'll always be like a 2x2, 3x3 and so on. And it's always a square. And you see that you often see it written like this, from this to this, or sometimes you might, so you say from this state to the next state. It'll make sense in a little bit. The other thing to remember about a transition matrix, important, is the columns always add up to 1. Add up to 1. So you can see where we're going to be talking about proportions or percentages, it's in proportions because they're in decimals, but it's generally explained using percentages. So a system can illustrate the difference between states. So a transition statement, the following transition statement describes the movement of delivery trucks between two locations. All right, so we're going to do this example here. So we've got the delivery trucks between two locations. So here they can set it up and they can say 70% of the trucks that park that start at A will park at A that night, and 30% think. So you've got this driving truck company, and they've got two locations where they can rest or put the trucks at the end of the day. So what they're saying is, if the trucks started at A, site A, 70% of them return, 70% go back and get parked at A again. Of some of the ones that start at A, 30% are going to end back at B on the next day. So they park at B. And then they give you the next piece of information. They say 60% of the trucks that park at B will return to B. So we're saying 60% there. And then they said some of them that start at B will end at A. So that's 40%. So we can set this up as a matrix, which you can see that they've done here. So we've got from A to B. So when you have here this arrow here, from A to A, you can see from A to A is 0.7. And then if I say from A to B is 0.3, and you can see here's the 30%. So if you look at those numbers there and you add up 0.7 and 0.3, you can see they add to 0.1. And then we can do the similar thing for the B site. So if we start, just remember a bit of this out. If we start at B and go to B, it's 60%. So you can see B to B was there. And then the last one from B to A was 40%. So we can see that there. So this is the transition matrix written here. And we're going to use this later on, but this lesson we're just working out how to set up a transition matrix, or if they give it us in words, how can we do it? So here they've given it in this is in word form, and this is the diagram here. So I redrew it up here, but you can get it also in a diagram. So the main thing to know that if you've done it right, they'll add up to 1. So remember, all transition matrices add up to 1. If they don't add up to 1, it's not a transition matrix. So it's a good way to know if you've done it right, or if they're asking you, is this a transition matrix? Unless it adds up to 1, it's not those columns, it's not 1. So what we'll do in the future, like in the next few lessons after this, we will use this transition to predict. So they might have so many trucks, and this is saying from day to day. So I might say, look, after 30 days, I want to know what the general gist is, how many trucks are staying at A and how many trucks at B. So I can use it in my business to know, what stock I'm going to hold, how I need to have this many trucks here, and that's what they're used for, these transition matrices. But we're just going to practice this setting up. So I've popped a couple. These aren't on your sheets, but I've popped a couple on here just to do with you because we're online. So you'll notice if you have 2 stations, like 2 places, then your square matrix is going to be a 2 by 2. So you're going to have, so here, this is talking about a car rental place, I think it was. So it was Bendigo and Colac. So you're going to say from here and Bendigo and Colac to there. So it could go there. So you can see we're going to have a 2 by 2. This will be a 2 by 2 because there's 2 places. The best one to do first when you're filling out these creating these transition matrices is always to do the one that goes back to itself. So what do I mean by that? I mean B to B is quite easy to see on the diagram. So you could look for the one that circles back to itself, and it says 80%. Now we don't write 80% because we need it to add up to 1. So we change it to a decimal and we write 0.8. So once I've done that one, as I said, it's easier to do the ones that go back to itself. So the C to C. So I'll make sure I fill in the C to C one next, and I can pop that one in, and that was 90%. Now you could look at the other arrows if you want and work it out, but we know these columns have to add up to 1. So that would make this one 0.2. And that would make this one 0.1. And I can work that out because this one has to be a 2 by 2. So there's no other spot. So it would have to equal that. So let's look at this next one. We have 3 places that, I think it's still a car rental place or something. So we've got Albury, Benalla and Wodonga. And so Albury, Benalla and Wodonga, and this is from here and they're going to there. Okay, so as I said, much easier if you do the ones to itself. So if I do the A to A, I'll look for A to A, that's still 70%. So I'll put in 0.7. If I look for the B to B, B to B, so B to B, B to B would be down here. So I pop that one in, and that's 0.77. Okay, and I'll do this W to W, which is 80%. So that one would be down here, 0.80. I can't fill in the rest of the columns by using the, add up to 1 trick because there's more than one gap. So I'm going to have to look at them. So I'm going to do this spot here, which is going from A to B. So I'm starting at A and I'm heading towards B, and I can see it's 20%. So this one becomes 0.2. Now because those 2 green numbers add up to 0.9, I know the last one should be 0.1, and I'll go check that. And that's starting from A and going to C, and there's that arrow, going to W, and there's that arrow there, and it is 10%. All right, so then let's have a look at the blue. So I'm starting here, starting at B and going to A. So I'm looking to the arrow that takes me to A, which is there. so it's 12%, 0.12. So those two blue numbers, they add up to 0.89. So the other one should be 11%. So let's have a look when we're going from B to W. So from B to W, yep, is 11%. So I'll pop that one in there. And let's do the last one, the purple one. So from W, so from here going to A is 5%. Now be really careful with the 5%. It's 0.5 when it's changed to a decimal. That's the common mistake. People, if you write, 0.5, that's 50%. So 5% is 0.05. So those two purple numbers add up to 0.85. So I should have 15% for the other one, which I do, 0.15. So as I said, they're all adding up to 1, and I know I've got them right. And that will be my transition matrix that I'll use.